Today we're going to be continuing working through our acids, bases and salts topic. So if you could get your Unit 1.9 booklet out now, we'll be working through that. Yesterday we started to look at the reactions of acids, beginning with the reactions of acids with metals. And what we said that was that when a metal reacts with an acid, we always produce a salt plus hydrogen. The name of the salt will depend on the metal and the acid that we use, but hydrogen will always be a product. It'll always be hydrogen gas that we give off. So how do we determine the name of our salt? Well, we'll do some examples off to the side here. So say, for example, we had sodium and we reacted that with hydrochloric acid. Okay, so we take the first part of our name of the salt from the metal, and that remains unchanged. So it's just sodium. And we take the second part of our name from the acid, but this part of the name does change. So if we have hydrochloric acid, it changes its ending to chloride. So the name of our salt is sodium chloride. So a salt has two names. You can think of it like a first name and a surname. The first name coming from the metal and remaining unchanged, and the surname coming from the acid, but it does change depending on the acid that we use. So we get sodium chloride, and then our other product will be hydrogen. We'll zoom out to give us a bit more room with the next one. Let's do another example, and that would be of potassium plus sulfuric acid. Okay, again, the first part of the name comes from the metal, and that remains unchanged. So the first name of our salt is potassium. Second part of the name comes from the acid, and that changes. So we can see here in your notes that sulfuric acid changes its ending to sulfate. So our salt is called potassium sulfate. And then our other product, as always, is hydrogen. Don't forget about the hydrogen being given off at the end. So hydrochloric acid and sulfuric acid are the only acids that you need to be familiar with. So remember that hydrochloric acid changes its ending to chloride. Sulfuric acid, its name to sulfate. Okay, so yesterday we started to look at a couple of examples of these reactions, and we only got doing the reaction of calcium plus hydrochloric acid before we had to go to assembly. So we need to fill in our observations here. So what did you see happening? Think about what you saw happening yesterday. Well, one of the observations is fizzing. So we've got a gas being given off, so there's always going to be fizzing or bubbling if you prefer to do it, to mention it that way. Another thing we noticed is that the metal disappears. So the calcium eventually disappeared as it reacts with all the acid. The next thing we're thinking about is the colour of the solution that we formed. Well, we didn't form a coloured solution, so we just say colourless solution formed. And that's a colourless solution of our salt that we formed, and we'll talk about what that was in a second. And the last observation is that if you felt round the walls of the test tube, you would have noticed that it would have been quite hot. So this reaction releases heat. Okay, so those are 4 observations, and you need to learn those observations in case they ask you in the exam what would be observed when a metal reacts with an acid. Now, in terms of our products, I know we filled this in yesterday, but we're going to get 2 products. So always think of your general equation, and I'll write it again here. Metal plus acid gives us a salt plus hydrogen. Okay, so our 2 products are always going to be a salt and hydrogen. Now the name of our salt depends on our metal and our acid. So we use calcium and hydrochloric acid. So the first part of the name comes from the metal, so it's going to be calcium. That's its first name. And then we used hydrochloric acid. And remember, hydrochloric changes to chloride. So we've got calcium chloride. And what else do we always have? Hydrogen. Okay, so that is the reaction of calcium with hydrochloric acid. Be familiar with those 4 observations. They are generally the same for every metal with an acid, and we'll see that with magnesium and sulfuric acid. So on the next slide, there's a video of the reaction of magnesium and sulfuric acid. Here we've got the second reaction of a metal with an acid. We've got sulfuric acid reacting with magnesium. So I've put the sulfuric acid in, and now I'm going to put my magnesium strip into the acid and collect the gas using this boiling chip. So I've got a couple of different observations here. I can see that I've got fizzing going on, and that's because of the hydrogen being given off. My metal is starting to disappear, so as it reacts with the acid, it disappears, a bit like our metal did when it reacted with water. I can see that I'm forming a colourless solution. It's not forming any blue or green or yellow solution, it's a colourless solution that's forming down here. And also if I feel around my test tube, I can feel that it's very, very warm, so there's heat being released as well. So just let some more of that react, and then I'm going to test my gas using the pop test. So to prove that this is hydrogen, I'm going to pass the gas I've collected through the Bunsen burner, and if it's hydrogen I should hear a squeaky pop. So my reaction is now finished, so I'm going to test my gas. So I'll turn my Bunsen flame to the blue flame, which is the hottest flame, and pass it through. And you can hear a nice squeaky pop, and you should have seen flames, and that's because actually what happens in the hydrogen test is that the hydrogen explodes. So the hydrogen reacts with the oxygen in the air and explodes, forming that flame. So let's recap what we observed in that experiment, and if you could write these observations in on your page, on page 5. Okay, so when magnesium reacted with sulfuric acid, the first thing that we saw was fizzing. And again, that was because of our hydrogen being given off. The second thing that we observed was that the metal eventually disappeared. So as it reacted with the acid, the magnesium disappeared into the solution. We don't say dissolves because that's technically not true. The magnesium doesn't technically dissolve. It reacts with the acid, and that's why it's used up and then disappears. We formed a colourless solution. And also there was heat released. So the sides of the test tube got very warm because of the heat being released. So what do you notice here? The 4 observations that you have for magnesium and sulfuric acid are exactly the same as the 4 observations you had for calcium and hydrochloric acid. So learn these 4 observations and they will apply to any metal and any acid. But what will be different is the products that you form. So the first thing I have is my salt being produced. So a metal plus acid gives us a salt plus hydrogen. And you always have to come back to these general equations when you're writing, when you're determining your products, because you'll know you get a salt and then you have to work out what your other product is, and in this case it's hydrogen. So always refer back to that general equation. So we reacted magnesium and sulfuric acid. First part of our name comes from the metal and that remains unchanged. So our first name of our salt is magnesium. Second part of the name comes from the acid and that does change. We use sulfuric acid and that changes its ending to sulfate. And what's our other product going to be? Hydrogen. And how did we test for that hydrogen? Well, flick over to page 6 and we'll talk about what the hydrogen test really is. So about halfway down page number 6 you have an explanation of the test for hydrogen. And as it says, we usually refer to it as the squeaky pop test. Now, if you were asked in an exam, what is the test for hydrogen? You would need to say this sentence. Apply a lighted splint to a test tube containing hydrogen. Now, we did this a bit differently. We passed it through a Bunsen burner. It just gives a clearer pop. But don't write that in the exam. Don't write that you passed a boiling tube of hydrogen through a Bunsen burner. The proper way to do it is to apply a lighted splint to a test tube containing hydrogen. So if you make a little note that that is the test for hydrogen, and then make a note that this is the positive result. So sometimes you'll be asked in an exam, it'll split it up into test. It'll say, how could you confirm that the gas is hydrogen? So it would be given in 2 sections. It would be test and result. So for test, you would write this, apply a lighted splint to a test tube containing hydrogen. And for the result, you would write a popping sound will result. That's the sort of language that you want to be using. So what's actually happening when we are testing for hydrogen? Well, you can see in this box here that what we're doing when we apply a lighted splint or we pass it through a Bunsen burner is we're actually causing the hydrogen to react with oxygen, and it does that explosively. So hydrogen reacts with oxygen and that's where we get the explosion. But interestingly, the only product we have is water. Okay, and that's why hydrogen can be used as a fuel, because it releases a lot of energy. You could see that even in my tiny test tube containing a small amount of hydrogen, there was quite a big explosion. So it releases a lot of energy, and so it's used as a fuel in rockets and also now in cars. And it's got a big advantage in that its only product is water. So it's not releasing harmful gases like carbon dioxide or sulfur dioxide that causes acid rain. It's just releasing water. So it's a non-polluting fuel. Now we need to make one little correction in your notes, and that's that this equation isn't balanced. So what we need to do that is just put a 2 in front of the hydrogen and a 2 in front of the water. So now our equation is balanced. So if you could update that in your notes. Okay, and it's equations that we're going to focus on now. What we're going to do is we're going to write equations for the 2 reactions that we did. Firstly for calcium and hydrochloric acid, and then for magnesium and sulfuric acid. So let's focus on magnesium and hydrochloric acid first of all. So we'll always start by writing our word equation. Now the start of our word equation is easy. It's just the 2 things that we reacted together. So calcium plus hydrochloric acid. Okay, so that's the start of it, but what's the end of it? Well, I need to think back to my general equation, and it might be a good idea, you will be writing 4 equations on this page, so it might be a good idea just to write the general equation at the top of your page. Salt plus hydrogen. So when we react calcium with hydrochloric acid, we're going to get a salt. And what is the name of my salt going to be? Well, I get the first part of my name from the metal, and that remains unchanged. So, first name of my salt is just calcium. Second part of my name comes from the acid, and that does change. Remember, hydrochloric acid changes to chloride. So we've got calcium chloride is the name of our salt. And what else are we going to have? Always hydrogen. Okay, so now for the slightly more tricky step. And that is writing our balance symbol equation. So we'll work on this one together, and then you can give it a go for magnesium and sulfuric acid. So when we write an equation from scratch, we always have to take each term individually and convert it to its formula. So we'll do that one by one, and do this stepwise, one by one. So the first thing we have is calcium. What is the formula for calcium? Well, that one's easy. I just look to my periodic table and see that calcium is Ca. So it's Ca plus, and my next thing is hydrochloric acid. Now, hydrochloric acid is one that you need to learn. You can do it from swap and drop with hydrogen and chlorine. The easiest way to do it is just to remember it, and that is that hydrochloric acid is HCl. So it's quite an easy one. Hydrochloric acid is HCl, and that's written on your previous page. Okay? So not too difficult so far. But here's where we get into a little bit of difficulty, where we have calcium chloride. And here I need to use my swap and drop. It's absolutely essential that you use swap and drop here. So remember stages of swap and drop. First is convert our names to formula. So we've got calcium and we've got chloride. So Ca and Cl. Second step is to work out our valencies. We'll have a look what group calcium is in. So take out your periodic table. Calcium is in group 2, and so its valency is 2. Chlorine is in group 7, and so its valency is 1. So when I swap and drop those, I get Ca1, Cl2. And then remember, I can ignore my 1s, and so my formula for calcium chloride is CaCl2. It's so important that you do your swap and drop, because otherwise you might have been tempted to just write CaCl, calcium chloride, but we need a 2 there. And then the last thing we have is hydrogen. And you might be tempted to just look at your periodic table and see that hydrogen is H and just write it as that. But remember, hydrogen is diatomic, and so we always have to write hydrogen as H2. Okay, now for balancing it. So we've written our symbol equation, now we need to balance it. First step, write down a list of all the elements that we have on the left hand side. So we've got calcium, we've got hydrogen, and we've got chlorine. And then the second step is to rewrite that on the right hand side. So calcium, hydrogen, and chlorine. Next step is to count up how many I have on the left hand side. So you can see that I've got 1 calcium, I have 1 hydrogen, and 1 chlorine. Now let's count it up on the right hand side. So again, I have 1 calcium, Now hydrogens, I've got H2, so that means I have 2 hydrogens. Chlorines then, I have Cl2, that means I have 2 chlorines. So you can see that our equation is not balanced, as I have 1 hydrogen and chlorine on the left hand side and 2 on the right hand side. Now the next stage, to remind you, is that we put big numbers in front of the formula, and it can only be big numbers in front of the formula. I can't put little numbers, say for example here, HCl2, because that would totally change the formula of my hydrochloric acid, and I cannot do that. So how am I going to get 2 hydrogens on the left hand side? So we just take one element at a time and try to fix it. So I have 1 and I need 2. So in order to change that, I can put a big 2 in front of my hydrochloric acid. The next step is essential. I must update my list for every element that affects. So instead of having 1 hydrogen, I now have 2. Instead of having 1 chlorine, I now have 2. Because this 2 in front of my hydrochloric acid, that multiplies everything in the formula by 2. And now you can see that as a result of just putting that 2 in, I've balanced my whole equation. So the balanced equation is Ca plus 2HCl gives me CaCl2 plus hydrogen. Okay, what I want you to do now is to have a go at writing your balance symbol equation for magnesium and sulfuric acid. So start by writing your word equation and then try writing your balance symbol equation. And just a little note to help you, sulfuric acid is H2SO4. That is the formula for sulfuric acid. It is on your previous page and you should learn that. That sulfuric acid is H2SO4. So hydrochloric acid is HCl, sulfuric acid is H2SO4. So pause this video now while you try and write that equation, and then we'll go over it. So hopefully you've had a go at writing that equation for magnesium and sulfuric acid. I've written again the general equation at the top, and that's something you should always keep in mind. So it should start with simply the two things that we're reacting together, and that's magnesium plus sulfuric acid react to give us, well, the first thing is a salt, but we need to name our salt. First part of the name comes from the metal, and that remains unchanged, so it's magnesium. Second part of the name from the acid, and that does change. Sulfuric acid changes to sulfate. And then our other product is always hydrogen plus hydrogen. Okay, now for the slightly trickier part, and that is writing our balance symbol equation. So we start off nice and easy, and that is magnesium is Mg. Sulfuric acid is H2SO4. And that's again something you should learn. Sulfuric acid is H2SO4. Reacts to give us magnesium sulfate. Here we need to do our swap and drop. So magnesium is Mg. Sulfate is one that I need to look at the back of my periodic table for. And sulfate appears as SO4 2 minus. So I look to this part for my formula and I write down everything there. So I write down everything minus apart from the charge. So I write down SO4. Please do not forget that little 4 at the end. Okay, now time for working out my valencies. For magnesium it's easy, I just look to its group number. It's group number 2, and so its valency is 2. And for sulfates then I look at the charge, and I can see that my charge is 2 minus. Because my charge is 2 minus, I just forget about the minus sign. My valency is then 2 for sulfate. So So it's just whatever number is in front of the charge, so 2 minus. If it was just minus, the valency would be 1. So the easiest way to do this is to actually cancel down before you start to swap and drop. So we can see that we've got a 2 to 2 ratio here. So we can cancel that down to 1 to 1. Okay. Then you'll remember that at the end we end up ignoring our ones. So what we're going to do now is swap and drop and ignore the ones at the same time. So what we'll end up with is just MgSO4. Now, if you want to do that the long way, I'll do that now. So the long way would be, again, magnesium, valency of 2, sulfate, valency of 2. If we swap and drop those, we get Mg2. Then we need to use brackets for our sulfate. So SO4 brackets 2. Then we can see that we've got a ratio here of 2 to 2. So we can cancel that down to 1 to 1. So it will be Mg1 SO4 1. I can ignore my ones. And so it's just Mg brackets SO4. And then because there's no number outside the brackets, I can now just write it as, I can remove my brackets and just write it as MgSO4. So my formula for magnesium sulfate is MgSO4. But again, had to do my swap and drop, couldn't have got there automatically. And then hydrogen is, again, H2. Don't forget that it's H2, not just H. Okay, now time for balancing. And again, I need to make a list on the left-hand side of the elements that I have. So I have magnesium, I have hydrogen, I have sulfur, and I have oxygen. I have a tight squeeze here. It's not going to work. Okay, and then I write my list on the right-hand side as well. So I've got magnesium, hydrogen, sulfur and oxygen. It's easiest just to write it in the same order. So now time to count up the elements on the left-hand side. I've got 1 magnesium. I've got H2, so that's 2 hydrogens, just 1 sulfur, and then I have O4, which means 4 oxygens. Then on the right-hand side, I have Mg, just 1 Mg, so that's 1. I have H2, so that's 2 hydrogens, S, so 1 sulfur, and O4, that means 4 oxygens. And you can see that the list on the left matches the list on the right, and so my equation is already balanced. So my equation for magnesium plus sulfuric acid is Mg plus H2SO4, arrow MgSO4 plus H2. At the bottom of page 6, you have 2 more equations that I want you to write, and they follow the same general formula. So always keep that in mind, that they're going to follow this formula. Metal plus acid gives us a salt plus hydrogen. So they're all going to follow that general equation. Metal plus acid gives us a salt plus hydrogen. So give that a go for aluminium and hydrochloric acid, and then zinc and sulfuric acid. Now remember, zinc is one that, to get its valency, you need to look at the back of the periodic table. So it'll appear at the back of the periodic table as Zn 2+. So think about that when you're writing the formula of zinc sulfate, the salt that you form. So pause this video while you have a go at those 2 equations, and then we'll go over them. Okay, so hopefully you'll have got both word equations and balanced symbol equations for these 2 reactions. So first of all, I have aluminium reacting with hydrochloric acid. And that's going to give me two products. I know that from my general equation. That's why it's so important to learn your general equation. Otherwise you won't know what this produces. So aluminium plus hydrochloric acid is going to give us a salt plus hydrogen. How do we name our salt? Well, we take the first part of the name from the metal, which is aluminium. So it reacts to give us aluminium. So aluminium, and then the second part of the name comes from the acid. And hydrochloric acid changes its name to chloride. So we form aluminium chloride. I'm just going to write it above here, I don't have room. Aluminium chloride plus hydrogen. It's always going to be, when a metal reacts with an acid, it's always going to be plus hydrogen at the end. So aluminium plus hydrochloric acid reacts to give me aluminium chloride plus hydrogen. So now for writing our balance symbol equation. Well, again, the left-hand side should be fairly straightforward. Aluminium, I look to my periodic table and see that the symbol for it is Al. Hydrochloric acid is HCl. And then aluminium chloride, I need to stop and have a think about aluminium chloride. And I need to do my swap and drop for that. So aluminium is Al and chloride is Cl. Aluminium is in group 3, and so it has a valency of 3. Chlorine is in group 7, and so it has a valency of 1. So when I swap and drop, I get Al1, Cl3. But as we know, we can ignore our 1s, and so my formula is AlCl3. AlCl3. So we have to do our swap and drop for that. Plus hydrogen, and again, always remember that it's H2. Now time to balance my equation. So first step is always make a list of my elements on the left hand side and then on the right hand side. So I've got aluminium, so write down Al, I've got hydrogen, and I've got chlorine. So Al, H and Cl. Okay, I then copy that list on the right hand side, Al, H and Cl. And then I count up how many of each type of element I have on the left hand side. So I have 1 aluminium, 1 hydrogen and 1 chlorine. On the right hand side I then have 1 aluminium, 2 hydrogens and 3 chlorines. So you can see that my equation is not balanced. Perhaps the easiest place to start with is to get from 2 chlorines or 2 hydrogens on the right to 2 hydrogens on the left. And I do that by adding a big 2 in front of my hydrochloric acid. And then I need to update my list for everything that changes. So that changes the number of hydrogens. I now have 2 hydrogens. And I now am going to have 2 chlorines. So you can see that I've fixed the problem of my hydrogens, but I haven't fixed the problems of my chlorine. Now, if I was to change this up to 3, you could see that it'll fix the problem of my chlorine. I'll have 3 chlorines, but now I'll have 3 hydrogens. But we have to do this step by step, and so we will do that now. So I'm going to change that number to 3 instead. So now I have 3 hydrogens and 3 chlorines. So my chlorines are happy, but my hydrogens are not. So how can I get 3 hydrogens on the right hand side? And I'm going to show you a little trick to speed this up. And that would be, if I've got 2 on the right hand side, what do I need to multiply that to get to 3? So 2 times what is 3? So if we think of it sort of mathematically, 2 times x is 3. So x is 3 over 2, or in other words, 1.5. So for the moment I can put 1.5 in front of my hydrogen, but I don't like having decimals, but that does fix my problem of my hydrogens. I now have 3 hydrogens on the right hand side. So my equation is balanced, but I don't like decimals. And so what I do to fix that is I just multiply everything in my equation by 2. So I multiply each of my balancing numbers by 2. So now, instead of having 1 Al, I have 2 Als. Instead of having 3 hydrochloric acids, I now have 6 hydrochloric acids. Instead of having 1 aluminium chlorides, I now have 2. And instead of having 1.5 hydrogens, I multiply that by 2 and I get 3 hydrogens. So yes, that's a lot of working out, but in the end you get 2 Al plus 6 HCl goes to give me 2 AlCl3 plus 3 H2. Now there's other ways you can do that, and if all else fails you can do it stepwise, working your way up to that. It would just take a very long time. So if you get to that stage where you can have a decimal in it and then just multiply everything by 2. Zinc and sulfuric acid should be a little bit easier. So make sure you have aluminium chloride in, because I'm going to delete that now. I'll write in the balancing numbers just in case you didn't get it. 2 Al plus 6 HCl gives me 2 AlCl3 plus 3 H2. Okay, zinc plus sulfuric acid now. So again, left hand side is easy. Zinc plus sulfuric acid reacts to give me, and you can almost see it, still see it at the top, and we're going to get a salt plus hydrogen. So again, first part of my name comes from the metal and that remains unchanged. So I've got zinc, second part of the name from the acid. Sorry, that should say sulfuric acid. Second part of the name from the acid, and sulfuric acid changes the end of its name to sulfate. So my salt is called zinc sulfate, and then my other product is always hydrogen. So it should be second nature to you now, just writing plus hydrogen at the end of these. Okay, now our symbol equation. So to start off, we look at what is zinc on the periodic table. Well, it's just Zn. Sulfuric acid, you need to have in your head, is H2SO4. Then we come to writing the formula for zinc sulfate. Again, I need to do my swap and drop. So zinc, I look at the back of the periodic table, and as I said earlier, it appears as Zn2+. That means that we look to the charge for the valency as we do with our molecular ions. And so because it's 2+, I just ignore the plus, and my valency is 2. Sulfate is SO4, 2-, so I write down SO4 and then my 2. Now, I've got a 2 to 2 ratio here, so I can cancel that down to 1 to 1. And then if I swap and drop and ignore my ones at the same time, you can see that these ones are going to cancel each other out, and so I'm going to end up with ZnSO4. So ZnSO4 for sulfate, zinc sulfate, plus H2 for hydrogen. Remember that it's diatomic. Okay, next step is make my list on the left hand side. So I've got zinc, I've got hydrogen, I've got sulfur, and I've got oxygen. So write that list on the right hand side: zinc, hydrogen, sulfur and oxygen. So count up how many I have on the left. I've got 1 zinc, 2 hydrogens, 1 sulfur, 4 oxygens. On the right hand side I have 1 zinc, 2 hydrogens, 1 sulfur, 4 oxygens. And so my lists match, and that means that my equation is balanced. So we don't need to make any changes to it. It's just Zn plus H2SO4 gives me ZnSO4 plus H2. Turn over the page to page 7, and we're now going to look at the reaction of acids with metal oxides and hydroxides. And again we have a general equation, but this is slightly different this time. So if we have, now we're going to be writing 2, so leave room for 2. If we have a metal oxide plus acid, again we produce a salt, but our other product is different. We now don't have hydrogen given off, but water instead. So if a metal oxide reacts with an acid, we get a salt plus water. And that's because this is a neutralization reaction. A metal oxide is a base, or if it's soluble, it's an alkali. So basically we've got an acid and a base reacting to give us a salt plus water. So this is a type of a neutralization reaction. It's the same then for metal hydroxides. Again, they are bases. Metal hydroxide plus acid gives us a salt plus water. So very similar general equation, but our side product is different. And we've got water produced rather than hydrogen. Now, we need to again be able to write, to name our salt. Now, this is named in exactly the same way as above, except there's just one part that we do slightly differently, and we ignore one part. So we'll do it off to the side here. So say, for example, we have magnesium oxide plus hydrochloric acid. Okay, so we're going to form a salt plus water. Let's name our salt now. Again, we get the first part of the name from the metal. But this time, rather than writing magnesium oxide something, we just take the name of the metal. So we ignore this oxide part. So the first part of the name is magnesium. So again, I'm just getting it from the metal. I'm ignoring the oxide or the hydroxide. Second part of the name, as before, comes from the acid, and we've got the same endings. The hydrochloric acid changes its ending to chloride. So we've got magnesium chloride plus water. Okay, let's do another example. Let's do potassium hydroxide plus sulfuric acid. And if you want to take down these examples, they might help, and colour code them to show where the names came from. So again, I take my first part of the name of the salt from my metal, and I just take my metal name and I ignore the hydroxide. It's as if it wasn't there. Potassium and the second part of the name from the acid. Sulfuric acid changes its ending to sulfate. So I've got potassium hydroxide plus sulfuric acid reacting to give me potassium sulfate plus water. So we name our salt in exactly the same way, but we just ignore the hydroxide or the oxide part. So going back to our sheet here, we're going to look at the example of how copper oxide reacts with sulfuric acid. So let's have a think first of all, what are we going to produce? So thinking of our general equation, This is a metal oxide, but it's exactly the same for hydroxide as well. Metal oxide plus acid gives us a salt plus water. Okay, so first thing is our salt that we produce, and we get that from the name of our metal. So we use the name of copper and ignore the oxide. But don't score that out in your sheet because it is copper oxide we're reacting with. So the name of our salt is copper. Second part of the name comes from the sulfuric acid. So it's going to produce copper sulfate plus water. Okay, and again there's a video on the next slide which will show you how this reaction happens. Okay, I'm now going to do the reaction of copper oxide and sulfuric acid as an example of how a metal oxide reacts with acid. So again I'm putting my sulfuric acid in my test tube and I'm going to add my copper oxide. Now this time I don't need to collect any gas because I'm not giving off any gas. So have a think about the two products that we're going to form. So when a metal oxide or a hydroxide reacts with acid, we get a salt plus water. So water's not a gas, water's a liquid, so that's not going to give off any bubbles. So we shouldn't expect to see any fizzing, but also we don't need to collect the gas to see what it is. So I'm going to add my copper oxide now, and you can see that it is a black powder. So I'll add that to my acid. And at first you don't really see anything happening, and we can confirm that there's no gas being given off as there's no bubbling. Now copper oxide is quite a non-reactive metal, and so we tend to need to heat it up when we want it to react. And so I'm going to put the reaction mixture into a hot water bath. Again, we still can't see very much happening. But slowly over time we should start to see a change happening. So remember that my copper oxide was a black powder, and we can describe sulfuric acid as a colourless solution. Remember not to say that it's a clear solution, because we can have clear coloured solutions, so like a blue clear solution or a pink clear solution. But this is colourless because it doesn't have a colour. Yes, it is also clear, but we describe it as a colourless solution. So hopefully you should start to see something happening now in our reaction first. So if I hold it up, you can start to see that we have a colour change happening. I'll leave it in my hot water for a little bit longer and we should be able to see that more clearly. So the hot water will speed up this reaction. But what's happening in here is my metal oxide is reacting with an acid, with the acid to give me a salt. So think about the name of the salt. I've got copper oxide and sulfuric acid. Now we know the first part of the name comes from the metal and the second part of the name comes from the salt, or from the acid. And so we've got copper from copper oxide, and then we're using sulfuric acid, and so the end of my name is copper sulfate. So what I'm forming here is a solution of copper sulfate. And you might already know that copper sulfate is a nice blue colour, and that explains the colour change I am seeing. Now if we left this over a long period of time, the blue colour would intensify more. But you can see that there's been a definite change here. So from our colourless solution of acid to a nice blue solution of our copper sulfate salt. And water is being given off as well. Now, any sort of bubbles that you see is just the water starting to boil because it's at quite a hot temperature. So I'll leave this in, and then I'll take a photo of it when it's completely reacted so you can see the nice blue colour. But your observations for this reaction, there's no fizzing, no gas given off, and all we see is that a colourless solution changes to blue. So on page 7 we need to fill in our observations for that reaction, and as we said there was no fizzing, no gas given off, and so our only observation for this is that colourless solution changes to blue. So we produced a nice blue solution from a colourless solution of sulfuric acid and copper oxide. And as we've already discussed, our products are copper, sulfate, and water, which explains why we don't have any gas given off. Now, time for our word equation. Okay, so word equation should be fairly simple. We've got copper oxide reacting with sulfuric acid to give us, now remember a general equation, it's going to be metal oxide plus acid gives us a salt plus water. So the name of our salt comes from our metal oxide and our acid. First part of the name from the metal oxide, and I ignore my oxide part, so it's just copper. Second part of the name from the acid, sulfuric acid, changes its ending to sulfate. And then I follow my general equation, see that I've got water being produced, so it's copper sulfate plus water. Okay, now in terms of your balanced symbol equation, copper oxide, we need to do our swap and drop. Copper oxide, it may appear on the back of your periodic table as Cu2+, but the valency of copper is usually always 2. It can be 1, but it's usually 2. It's 2 in this case. So Cu2, oxide is 2. So when I swap and drop those, I end up with Cu2O2, but I can cancel that down to Cu1O1, and I can ignore my 1s and just end up with CuO. So copper oxide. So I'll rub that out to give us a bit of space. So it's CuO plus sulfuric acid is H2SO4. Reacts to give us copper sulfate. Now again we need to do our swap and drop. Again, copper has a valency of 2. We know that sulfate is SO4 2-, so it has a valency of 2. We can cancel down at the start to make this a little bit easier. So we can cancel down to Cu1 SO4 1. So when we swap and drop that, we're going to end up ignoring our 1s, and so for our formula for copper oxide, or copper sulfate, is just CuSO4. So CuSO4 plus water, hopefully you know, is H2O. Okay, in terms of balancing it now, we need to make a list on the left hand side and make a list on the right hand side. So I'm just going to do it down here. I've got copper, I've got oxygen, I've got hydrogen, and I've got sulfur. On the right hand side I have copper, oxygen, hydrogen and sulfur. So I just write that in the same order. Count up how many I have on the left. I have 1 copper, I have 1 oxygen here, but 4 oxygens here, so it needs to be the total number, so that's 5. I have 2 hydrogens and 1 sulfur. On the right hand side, again 1 copper, and now I've got 4 plus 1 oxygen is 5. 2 hydrogens and 1 sulfur. So you can see that my equation is balanced. So CuO plus H2SO4 reacts to give us CuSO4 plus H2O. Okay, what I want you to do now is have a go at writing these equations, word and symbol equations, for the reactions of sodium hydroxide and sulfuric acid.